Assalamu alaikum students. I hope you will be doing good. Today we are going to solve the problem number 2 from exercise 2.3. It's from class intermediate mathematics in board. It's about to find the nth term and then limit of the sequence. So we have already made the video of this question that you can find on my YouTube channel. So today we are going to find the nth term or general term for this sequence, and then finding the limit of that sequence. So this is a kind of sequence which is the combination of two or three sequences at the same time. So first of all, we would like to see that whether what can be its nth term or general term. So we are finding for that. It's not a point or decimal in between this 1 and 2. It's the symbol of multiplication. When you write a sequence, you will put a dot between two numbers. So this means it's multiply 1 multiply 2, or 3 multiply 4, and then 5 times 6, or 5 times 6, and then 7 times 8. There are a few sequences that I can see. This is 1, and then this is 3, and this is 5. So a sequence which is like 1 1 and then 3 and then 5 and so on. This is a one sequence, and the second is 2 4 6, and this also goes on and on and on. So this is 2 4 6. I will write like this way. Then we have 3 5 and 7, so I can write 3 5 7. This is also another sequence. And then we have 4 6 and 8, so this is 4 6 and 8. These are the sequences which were kind of combined together and then formed a new type of sequence, which is being shown here to you. First we will find the nth term or general term for this sequence, and then we will find the nth term or general term for this sequence, and so on. Then we will arrange all these general terms the way they are written in this sequence. So how to find the nth term or general term for this sequence? So for this sequence, first of all, we will find out the difference, which is 5 minus 3. This is an arithmetic sequence, hence we can use the formula a plus n minus 1 into d. So here a is 1, the first number, then n, which is n. We will keep n as it is because we are finding the nth term, minus 1, and d means the difference between the two terms, which is 5 minus 3 or 3 minus 1. In any case, it is 2 every time, because when you subtract 5, or when you subtract 3 from 5, you will get 2, which is the value of t. And then if you subtract 1 from 3, you will again get 2. So the difference between each consecutive term in this sequence is 2, hence we will write 2 in place of d. So when you simplify this, you will get 1 plus 2n minus 2, and the nth term will be minus 2n plus 1. We have 2n and minus 1. So the nth term for this sequence is 2n minus 1. Okay, now we will find the nth term for this, or general term for this sequence. So we can use this general formula for all these sequences, because these all sequences are arithmetic sequences. Okay, here a is 2 plus n, we will keep n as it is, minus 1, and d, which is again 2, because 6 minus 4 is 2, and then 4 minus 2 is 2, so we have d2. And if you simplify this, you can have 2 plus 2n minus 2, minus 2 plus 2 cancelled, and you have a term which is 2n. This is the general formula or general term for this sequence. That means if you put 1 or the position number of any term, you can find that number by putting that position number in place of n. So if you write 1, you will get 2 because the number in first position is 2, and then the number in second position, that means if you put n is equal to 2, you will get 4. So the second value is 4, and then if you put 3 in place of n, you will get 6. That means the third value will be 6. So this is the pattern or procedure that we can get any number in this sequence by putting that position number in place of n. So this is the general formula or general term for the sequence an, which is 2, 4, 6, and so on. Now you can find out the sequence or general term for this sequence. So again, this is an arithmetic sequence. So we will put the values in this formula to get the general term of this sequence. So the value of a in this sequence is 3, and plus n, we will write n as it is minus 1 into t. So the value of t is 7 minus 5 is 2. Hence we will simplify this: 3 plus 2 n minus 2 plus 3 minus 2, we have 2n plus 1. This is the general term of this sequence, and the general term for this sequence is the first value, which is 4, plus n as it is minus 1 d. 8 minus 6 is 2, 6 minus 4 is 2, again 2. So we have, if you multiply this 2 with this number and with this number, you will get 4 plus 2 n minus 2. Then 4 minus 2 is 2, so it's 2n plus 2. This is the general term for this sequence. Okay, hence we have found the general terms for all these sequences. Now we can arrange these general terms like the way they are written here. For the first sequence, we have 2n minus 1. We will write an is equal to 2n minus 1, and then it is being multiplied with the second one, which is 2, 4, 6, and the general term for that is 2n. And then in denominator, we have this sequence. The general term for this sequence is 2n plus 1. We will write here, and then for this sequence 4, 6, and 8, we have general term, which is 2n plus 2. Now we first simplify this. This is the general term. You can simplify further, and you can get the final answer. When you multiply 2n with this 2n, it is 4n square minus 2n. And in denominator, when you multiply 2n with 2n, you will get 4n square. Then 2n times 2 is 4n, and then plus 2n. So 1 into 2 is plus 2n, and then 1 into 2 is 2. So an is 4n square minus 2n divided by 4n square plus 6 and plus 2. So this is the general formula for the sequence which is written here. And now that means when you put 1 in place of this, in place of this, in place of n in this sequence, you will get the value of this term. Like when you put 1 here, it is 4 minus 2, you will get 2 in numerator, and then when you put n here, you will get a 12 in place of this. So you have 2 by 12. Okay, so barrel, we are not supposed to find out the terms of this sequence, but we are supposed to find out the limit of the sequence. So now we are going to find the limit. To find the limit of this sequence. Limit of this sequence. So what we will do, we will say limit n tends to infinity of an is equal to limit n tends to infinity of 4n square minus 2n over 4n square plus 6n plus 2. So this whole value. Now here you see we have 4n square. We will take that 4n square as a common. So we will write here limit n tends to infinity of n square, which will come out. Then we have 4, we are left with 4 here, minus 2. And if n square is common, we will cancel one n with this n. We still have one n. We can write that n into the denominator of this 2. Okay, so in this place we have n square as a common, which is 4 plus, and then this will be 6 over n, then plus 2 over n square. So these are the values after taking limit. Now we will apply that limit. You can write applying the limit. Okay, so what we have, limit n tends to infinity on this side of an, this will be equal to 4 minus 2 over infinity divided by 4 plus 6 over infinity plus 2 over infinity square, which is again infinity. And you know that anything upon infinity is 0, or like 1 over infinity, which is equal to 0. So limit n tends to infinity of an is equal to 4 minus 0 uh, over this will be 4 plus 0 plus this is again 0. So it's 4 over 4, which is equal to 1. Hence the limit of this sequence will be equal to 1. When we increase n towards infinity, we will get the number 1 in the answer. So this is your answer, or this is the limit of this sequence. And this means that if you increase n, if you increase the value of n towards infinity, this function will give you the result which will be equal to 1. Or that's all about today's video. I hope you understood this. And if you have any question, or if you want to ask any question, you can write in comments. So for more videos, like and subscribe and share these videos to reach the other students. Thank you very much. Allah Nikam.